Hello class, it's Mr. Dubay again, and welcome to the day 4 of Unit 12. So it's Unit 12 Statistics, day 4. And today we're going to be learning about more types of regression. So we've already learned about linear regression. And we have a type of calculator functions to find the linear regression. So today what we'll be focusing on is 3 new types: logarithmic, exponential, and power. What I need you to do now is take a moment, pause the video, and copy down these notes. What these notes describe is how to recognize each type of regression. It's not telling us specifically how to find the regression, it's telling us what the regression will look like. So most of the time in questions you'll be told which type of regression to use, but in case you're not, you need to look at the data set. This is what each type of regression would look like. So let's begin with the first example. Here I have a table which shows the years from 1980 to 2000. Let's be specific here. This is something we haven't seen yet. It says let x equal 0 represent 1980. So what I would need to do is I need to change what my x values represent. So 1980 would be 0. 1985, now that would be 5 years after 1980, so that would be 5, 10, 15, and finally 20. It doesn't say anything about changing my y values, so that's okay. So after answering these questions, after reading the question, we want to focus on how to answer it. So what we need to do is the same steps as we did from the day before, as I would enter my data into a list and spreadsheet on the graphing calculator. Once I've entered my data into a list and spreadsheet, I would click Menu, Number 4, Statistics, Stat Calculation. In this one here, like I said, it tells us what type of regression we're looking for. So I'd make a linear regression. After doing that, I'd be able to find my m and my b value. So here, I found in my graphing calculator that y was equal to 1.08x plus 13.4. So now that I have my equation written, that's important that we always rewrite the equation of my regression. Now that I have that, the question asks us, what will the enrollment be in the year 2010? So what I need to find is what input value that would be. So the year 2010 would be 30 years after 1980. So like I said, it's an input value, it's years. So I'd substitute that in for x. So when I answer these, it's important that I substitute that value in for the x. So y equals 1.08 times 30 plus 13.4, and that would give me y equals 45.8. So the enrollment for that year would be 45.8. If I was looking on if I was looking at the table, I would have my x and my y values here. I'd have let's look at when it occurs. So it would be 28, 29, 30, 31. These values would be, my y values would be 43.64, 44.72, 45.8, 46.88. So this is something we've seen before. We were looking at the linear regression, but now it's more important that we're actually doing something with the regression. The questions are going to ask us to do something with the equation. Very good. So let's take a look at another example. So take a moment, pause the video, write down your question and the table. So here we see that it asks for a different type of regression. Specifically, it asks for an exponential regression. So the difference here would be that after I've read the question, paying close attention to rounding, I would enter my data into a spreadsheet. So it goes read, enter data, and now I need to find the regression. So instead of clicking on linear regression, I would actually find my exponential regression. So looking at the exponential regression, I would find both my A and my B values that are outputted onto the spreadsheet. What I found was I got my Y to equal 379.92 when rounded to the nearest hundredth times 1.04 raised to a power of x when rounded to the nearest hundredth. Now we need to focus on what the second part of the question is asking. Using this equation, find the value of her stock to the nearest dollar after 10 years of her initial purchase. So 10 years, is that an input or an output? It would be an input, it would be an x value. So to get full credit, I need to first show me substituting that value in 1.04 raised to a power of 10. And what I got is an answer of $552 because it said round to the nearest dollar. Take a moment, copy down the notes, and we'll keep moving. Next example, example number 3. Take a moment and copy down these notes. So, the trick about this question is it doesn't give us a table. So we actually need to construct a table. So it says that here, I would say my laps, I would make that my x value, and then I would make my seconds my y value. So for 1 lap, it was 33, 2 laps, 38, 3 laps, 42, 5 laps, 50, and finally 7 laps was 54. So, rereading the question, I found that this one again is asking for a different type of regression equation. This one here is asking for a powers regression equation. So following the same steps, I would first read the question. I would enter my data into this list and spreadsheet. And now we've learned how to do a linear regression, an exponential regression. This is just another function on the graphing calculator, a power regression. When I find my power regression, I find that y is equal to 32.35. So now because it's a power equation, I would have times x raised to a power of 0.26. Be paying close attention to what my rounding needs to be. It was to the nearest hundredth. So continuing on with the question, it asked me to use the Logarithmic regression equation to estimate the number of seconds. So it's asking me to find the number of seconds given that it's her 10th lap. So the 10th lap, would that be an input or an output? It would be an input. So I'd substitute that 10 in for my x value. So we need to make sure that we're writing our table, our regression equation, and now I want to actually answer the question. So 32.35 times 10 raised to a power of 0.26. When I evaluate that on my calculator, I find to the nearest tenth of a second that it was 58.9 seconds. Take a moment and copy down these notes. Moving right along, let's take a look at this fourth and final example. Here, we need to make sure that we read the question carefully, and we look at the table. So this question is going to be asking for actually our third different regression equation. It's going to be a logarithmic regression equation. So you see how important reading is here, because if you give the wrong type of equation, you're going to get the question wrong right from the very beginning. These are very easy questions. You just need to make sure that you're answering the question correctly. So when I I input my data into a list and spreadsheet on the graphing calculator, and I do my stat calculation, I'm going to click logarithmic regression. When I do that, I find that my logarithmic regression is equal to y equals 13 point. This one's actually pretty large. It asked me to round to the nearest 10,000th, so that's 4 decimal places. 13.0134 plus. So now I actually got a negative b value, so I get negative 7.3135 ln of x. Ran out of room there, my apologies. I'll rewrite that better in the next question. So y equals 13.0134 plus a negative 7.3135 times ln of x. So the question asks, based on my equation, what would be my chill factor when the wind speed is... Oh, that's actually a two-part question, my apologies. Using the equation, find the wind chill factor to the nearest degree when the wind speed is 50 miles. So 50 miles, what would that be? It would be my input value. So first I would have to do y is equal to 13.0134. I'm looking to substitute that 50 in for my x value. 135 ln of 50. Natural log, ln. When I do this calculation, I get y equals negative 15.5972. And as for the nearest degree, so I find that y is equal to negative 16 degrees. So you got to be careful here. This is a two-part question. First it asks for when the wind speed is 50 miles. Now it's asking for a different question. It's asking for when the wind chill is 0. Think about that. Is that an input or an output? It would actually be an output this time. So I would set my function equal to this. So I would say that 0 is equal to 13.0134 plus a negative 7.3135 ln of x. So now I would want to simplify, and I would subtract my 13.0134, negative 13.0134 equal to negative 7.3135 ln of x. Divide by the negative 7.3135, and I get ln of x equal to 1.77937. So we need to think back in the past. I want to get x by itself, but I have that natural log function there. We need to think back to the logarithmic and exponentials unit. How would I get x by itself? Well, x would actually be equal to, right now it's in logarithmic form, I need to change it to exponential form. So remember this has a base of e. So what I actually have is x is equal to e raised to a power of 1.77937. Plug that in my graphing calculator, and I get x to equal 59.9261, which would be 6 miles per hour. I thank you guys for listening. Take a moment and copy down whatever notes you need, and have a great day.